Good afternoon, everyone. My name is Sumit Kumar. I am PMR of PhD Research Scholar at IIT ISM Dhanbad. I am going to take the course of Geotechnical Engineering 2 in this interaction. Am I audible? Am I audible to everyone?
Yes, sir.
Okay. Thank you, thank you. Okay. Then we can start, I think so. Basically, it is 3-5. And if someone more come to join, should we wait or should we start?
Can we start it, sir?
Okay. Let's start. Other will join in the midway. There is no problem with that. Okay. Then again, I will start with my introduction. Afterward, I will go ahead with the content which I am going to discuss today. Okay. In the meanwhile, anything you have to tell regarding the audio or video quality, you can pin me. You can text me in the message box. I will look after that. Okay. Then I will again start with my introduction, introducing myself, and go ahead. So, my name is Sumit. I am PMR Research Scholar at IIT ISM Dhanbad. I am going to take the course of Geotechnical Engineering 2, in which we interact with you and discuss the several topics in this regard. Whatever the topic you have read in the videos from the PMRF lectures by DN Singh sir, and that I will try to revise for you and also take some of the questions from there that will help you in your assignment as well as that will also ultimately help in the exams which is going to held in the October, by which you are getting the certificate. And this meeting is scheduled on Saturday 3 to 5 every week, and it will remain in the same manner. And in this interaction, I will also try to interact with you. I will also take your questions. In the meanwhile, earlier, whatever I have to communicate with you, I will communicate it with you. Afterwards, I will take your questions as well, up to some extent. But I don't think so that's needed. But if needed, that will be warmly welcome. And I also want to tell you that I am recording this lecture, so I will upload this on the YouTube as well. If someone of you on any day have some other work, so you can see over there as well, and that link will be shared with you. And the presentation or the course material, whatever I will discuss over here, will be shared with you by the NPTEL team, and you can go through that. And in my presentation, I try to cover all those aspects which sir has taken over there that will help you to study in a. This is also a quick revision for you as well. I have made the presentation little wider. That will help you ultimately at the end of your coursework, and it will with you throughout the lifetime, and it will enhance your capability in taking this subject. And apart from that, I also want to mention that this course is, I think, I will contribute in some way in your life through this course. Okay. Now I will start sharing my presentation and begin our class. Okay. Now we will start our discussion. So first of all, this is the coursework named Geotechnical Engineering 2, and it is taught by Professor DN Singh sir, who is from IIT Bombay. He is a very well-known person. Known, I am no one to introduce him. And this is the course about the geotechnical engineering tool. So, as you know, the pre-request for this course is at the geotechnical engineering one, and that is also known as the soil mechanics at several organizations. So, I will tell you that what is the basic requirement of the geotechnical engineering one. Basically, if you are going through this course, you must have some knowledge about the geotechnical, some not geotechnical engineering one. Basically, those concepts will be implemented in some manner that will help to solve the practical life problem through this course. And you have seen that in geotechnical engineering one, you have read the basic term related to soil, and soil is something everyone has been interacted with. Either he is a civil engineer or either he is a common one. Man, everyone have some of the issue. Every day we have seen that some of the news about some failure takes place. These days, the news are wide that due to the rainfall in Himachal Pradesh or Uttarakhand, several landslides take place. Several videos you have also gone through. So that is the problem related to soil. In the geotechnical engineering one, you have read the basic soil property like void ratio, permeability, and many more things. That's application will be taken in this coursework. So hope I am able to communicate with you what are the points need to be communicated. So let's start our discussion from here. So first of all, the basic thing is that the what is the shear strength? The shear, whenever we say about the strength is a parameter which we came across whenever you go to the course of the strength of material. We always have interacted with the strength, that is the tensile strength, compressive strength. But you also know that the shear is also over there. But when we came in the soil mechanics, geotechnical engineering, there the shear strength is the prime concerns which need to be taken care of. Here the shear strength of soil is maintained. We never say that the tensile strength of soil or the compressive strength of soil. We normally deal in the shear strength. Compressive strength is a factor over there, but the shear strength is the first aspects which we have to taken care of during the our course of the geotechnical engineering too. So first of all, start with the definition that what is the shear strength is and how the shear strength of soil is important for us. These are the main factor which needed to be communicated. Basically, if we doesn't know that we why we are studying a specific term, if so we didn't get the interest in that topic. So first of all, this what is shear strength we are going to see. So shear strength of the soil is the ability of soil mass to resist the shear force. Basically, the soil must have some strength, and that strength of soil make it to keep it at a specific place. And when there is some stress is coming, when the shear stress is applied due to any action, the shear strength resists it. And when the shear stress increases by a certain value, the soil ultimately gets stress. I will also show you those things with some images in the subsequent slides. So here the shear strength is the important property in geotechnical engineering. There is the no doubt in that. Basically, shear strength is that term which extensively determines the stability and the load bearing capacity of soil structure such as foundation, retaining wall, and slopes. Mostly we have seen that the slope failure takes place. That is the prime concern behind that is only one and only is the shear strength. Shear strength of the soil get failed, shear failure takes place. That's why mostly the slope failure will be seen. Moving on, and the shear strength of soil is represented mainly by the two parameter. One is the cohesion and one is internal friction. If you are little bit familiar with that, you must know this term. But in a meanwhile, I will define each and every term in little detail as well. That what are the term and how they are conveying to us. So the cohesion represents the shear strength of soil due to which the intermolecular force and is more significant in the cohesive soil. Yeah, you know that the in cohesive soil only, clay soil only, the cohesion has more important. But when we go in the practical situation, now very we come to interact with the C5 soil. No soil is ultimately sea soil, and no soil is only 5 soil. Basically, purely sandy, purely clay is a case, but C5 soil is predominant in nature, uh, not in nature, but at many places you find that. So you have to interrelate those concepts as well. So the angle of internal friction represent the resistance of soil particle to sliding, and each more relevant in the cohesionless soil. I already said that the cohesive soil, and that is the clay soil, the cohesion is the most important property, while in the sandy soil the angle of internal friction is the prime importance. As we go forward in the course, not today, we will come to know that during the triaxial test, the different tests are also there, but during the triaxial test we come to know that how the cohesion and how the phi is taken into account in order to solve the real life problems related to the shear stress. Okay, I think I will properly getting to communicate you, and if any one of you have any problem related to my audio is not clear, so you can text me, as well as at some point of time you can stop me and ask me that my audio is clear or not. Okay, so first of all, as I said that there are several tests are also there which are used to determine the shear strength of soil. The most important is the direct shear test. The laboratory test as well as field test are also there. And the triaxial test and direct shear test which is mentioned over here is the laboratory test, and in by which we get the shear strength. In the next week we are going to discuss some of those tests in which we specifically describe that how these tests takes place, what are the factors in different tests will we will concerned with. Those things will be discussed in the next class, but this is the basic introduction class. As I think you most of you have gone through the lectures of sir, you have seen that the basic concepts is discussed over here, but these basic concepts are very important. Ultimately these concepts will help you up to the last of this course, so you must have the understanding of these things as well. Here I am discussing the topics. In coming slides I have also taken the some of the problems specifically over there. Sir, I also discussed those problem, but I have given the solution for those problem over here, so that will help you in some way. Okay. Now, as I earlier said that the importance is the most important criteria before studying, before anything. Anything we are going to buy, we first of all see that is it important for me. If we are not thinking, then we are going blindly to take any commodity for us. But in real life situation, we should be aware about that is this thing is important. So if anything we are studying, so what is its importance in that context need to be entertained. So in geotechnical structure, the safety is the most important thing, and the safety, first of all, any construction takes place, the everything is stood on the soil only. So the strength of soil need to be considered, and when we talk about the strength of the soil, most of the time we are talking about the shear strength of soil. And if the shear strength of soil get increased to the critical value, that is the shear stress applied is above the critical shear strength value of the soil, then the structure is going to collapse, and which will lead to the huge damage of life as well as property, and which has been seen in previous sometimes. So these aspects need to be taken care of. We have seen that you must have came across the news of the Joshi Mutt. Sometime early it is widely in news. Over there also the cracks are getting developed in the several structures. The some or more region is that the differential settlement, and that differential settlement also takes place due to the sum of the region of soils only. May or may not be, but the reports will come and that will justify that what are the main cause. But the primarily it could be said that the effective stress is going to be zero. I think so. You came across the effective stress during your geotechnical engineering course one, geotechnical engineering one. So I don't think I need to discuss those terms. I can say those terms directly, and you will get those terms. I think so. If not, then you can stop me and you can ask me, but I will think that you will understand those terms. Okay. So the strength of soil is very important in any aspects, any construction. If that construction is taken in the plain region or the expensive soil or in a hilly terrain, everywhere the strength of soil need to be taken care of. Even the biggest from construction of the small two-story building to the construction of 40-story building or the 50-story building, the everything constructed on the soil and first of the soil need to be monitored that it will be sufficient to that amount of load. If not, then what are the improvement, the ground improvement we need to be provided in order to sustain those load. Otherwise we will not going to construct the superstructure over there up to that extent which we are planning. So that need to be taken care of. So the shear strength is required to make the estimate of the load bearing capacity of soil and is stability of the geotechnical structure, and it is analyzes the stress strain characteristics of soil in as well. Basically, the stress strain term you are familiar with from the your strength of material course. So the stress strain characteristics how get interrelated will be one of the aspects in soil is also the factor of the shear strength. Moving on, the now the importance of shear strength, some more importance of shear strength is also there. And what are those? That the shear strength is a critical factor, and it is specifically a critical factor because the shear strength is that term which will justify the structure need to be constructed or not over the specific locations. And the shear strength, the understanding of shear strength is essential for designing the foundation. Basically, when we construct the foundation in this course only, you will come to know that the different types of failures in soils is also taken care of. Over there, you will see that what are the factor which will result in the failures of the slopes or retaining walls or any structure. So the shear strength play the most important role over there. And I discussed earlier in the introduction slide only that the landslide is a major problem in India, specifically in when you go in the hilly terrain, Uttarakhand, Uttaranchal, or in northeast. Over there, you see that there are the very good place to visit where but the hilly terrain is there, but that will ultimately get damaged due to the failure of soils. And we have seen at several times that several highway get blocked due to the snow failure. So that need to be taken care of. Now, the we will discuss about shear strength in the granular soil, that is the sandy soil, as well as in the cohesive soil. So, first of the term is that how the shear strength in granular soil is we will look into. So, the granular soil, such as the sand, exhibits unique behavior under the stress. In flexible boundary, the granular soil tend to flow when subjected to stress, while in the rigid boundary, the volumetric deformation occur, and it takes place. It ultimately lead to the change in the shape and density of soil. So that is one of the concern. If the shape and density get changes, the soil property also ultimately get changes, which will maybe result in the uh, critically huge damage for the superstructure which is constructed over there. Either it is a road or a building. It irrespective of that, but the change in the characteristics of soil due to any region is a very concern for the civil engineers. And the rolling mechanism is also one of the important mechanism which is taken care of during the shear strength of the granular soil. Now we talk about the shear strength in the cohesive soil. The cohesive soil, specifically clay sea soil, we have discussed earlier that the sea cohesion is important in the cohesive soil, while phi is important in the sandy soil. So for the in cohesive soil, the special consideration shear strength is taken care of. And why this is? Because there is if the permeability get decreases, permeability also get decreases due to decreasing in permeability. The prevent consolidation settlement are the key objective in the compaction compacting cohesive soil. we compact the cohesive soil for that manner only. And the development of shear stress and slippage is a common in cohesive soil under excessive loading. Huh? This is the one of the prime concern things which we came across during the several occasions when we go to read the any paper or any news articles. We will come to see that these things happens not in the news article but specifically papers I am mentioning. Okay. Now the excessive loading and shear failures. These terms are also important. That the excessive loading can lead to shear failure. We have seen that at several occasions, at several places, the load are put so much that due to on the name of development, we are the engineers. We have to concern about the sustainable development. So the nature also need to be balanced, that the sustainable development need to be taken care of. So excessive load sometimes on basically we have seen that in a hilly terrain, the earlier the very less infrastructure is there, very less buildings are there. If the buildings are constructed, you need to be do the preliminary study that what is the effect of those terms. I am not talking against that the development need not to be taken, but development need to be taken in that manner that the nature doesn't suffer, because nothing is free in this world in real manner. If we if we take more from the nature, nature will also take the cost from us in one way or the another. So it need to be taken care of that the nature has provided so much thing to us. So the sustainable development, which is the wide term, which is also in the come in day to day life, that we engineers, not specifically civil engineers, but any engineers need to be taken care of the sustainable development. So excessive loading lead to the shear failure. So the preliminary soil study need to be taken care of, that how much load it will take, and what type of structure need to be created so that the load will be less and it will not ultimately result in the failure. Severe failures can result in the landslides, rock falls, and rock falls are seen in day-to-day life at several occasions at several places. And the understanding the factor contributing the severe failure is the crucial in the designing the safe and stable structures. So these are the important things which we need to be considering. Now, some more points about the shear strength is that it is the fundamental concept in geotechnical engineering. As you have seen that when we start this topic with the shear strength only, it is a fundamental concept. On the basis of shear strength, we can say that this specific location, the soil have this much shear strength. So how much load it is going to take and how it will help the design engineers, specifically the structural engineers, to design a building of the specific load. Basically, in any construction, first of all, the civil engineers is going for the geotechnical engineer. They will study that how the soil behave, what is the strength of soil by various tests, that how the soil behaves, what are the soil properties. Afterwards, on the basis of that, the strength of soil is calculated, and afterwards, any construction is going to take place on that location. So excessive loading can lead to the settlement and the shear failure, which have a severe consequences, and those consequences has been seen at several occasions as well. And the shear strength is a key factor in the designing foundation. When you go across in when we go in foundation engineering, slope, active pressure, or passive earth pressure, you see that the shear strength is one of the most important factor over there. So now we talk about the state of stresses. Okay, the state of stresses is one of the important term. We talk about the normal stress and shear stress and their interrelation. That if we take out the specific soil block, if we know that the sigma x is this much and sigma y is this much, then how we will how we will come to know that the ultimate what will be the normal stress and what will be the shear stress over there. So those things are taken care of, and those things need to be understood, and that will be seen over here. Here the in by two method, one is the analytical method where the interrelation is there, and another is the Mohr circle method, and that is a very important. Basically, when you go to find the term like the interrelation for the triaxial test, there the sigma 1, sigma 3 are the various terms which are over there. So that need to be entertained, that how it will be calculated using the different approaches. So we will going to see that one right now. Okay. Okay, so the stresses is the result of the external forces, and we know that the external forces are acting on a soil mass. So the critical soil mass lead to the formation of plains. When we say that the soil get filled, okay, I will say this with a more better way with this example. That over here you can see that the several blocks are there. The soil gets filled in this manner only, but what is the reason that it will fail in this manner only? Is there any things which will result in the failure in this manner? It may fail. It may fail if we 1 minute. It may fail in some other. You can see my arrow of my mouse. Hello. Okay. Okay, then you can find that uh, it can fail through this way, it can fail through this way. But what is the reason so that it will get failed in this manner only? There must be some region. So that region is the critical combination. Basically, the shear strength of soil is very less shear strength of soil. The shear stress which is applied surpasses the critical shear strength over there. That's why the failure takes place in this manner only, not in another manner. Because it is the important to understand that the shear failure of the soil only takes place because of the shear stress which is coming on that soil get exceeded to the strength of the soil at that point, and that is the analysis which we are going to understand. Over here you see that the several blocks are there, one, two, three, four, from top to bottom, one, two, three, four blocks are there. We go further, then we will also understand that at what location what type of test need to be done, at which location direct shear strength test, at which location triaxial test, uh, or the different test will give the appropriate result. That is also the one of the problem is specifically if you are preparing for engineering services or get exam over there. These are the questions which is framed that the at which section the which test will be prevalent, which test will lead to test will convey our purpose, which test will help give the result in the proper manner, that we will understand, and that we will discuss in the subsequent slides, not subsequent slides, subsequent classes, because the test is not taken care in the first week lecture curriculum. So we will limit, we have a limitation that we will stay up to that what is taken in the class. So here the shear stress applied each get exceeded to the shear strength of the soil at that location, due to which the failure takes place. You need to understand this thing. Okay, moving on. Here the in the last picture you have seen that the detached body is there and the parent body is there. Now you can see with the real life images as well that in the real life images the failure takes place. The failure takes in this manner only, and this is because that failure takes place in this manner only because the the soil mass over here get the critical combination. In that case, that the shear stress applied at that point will exceed the critical shear strength over there, that will lead to failure in this manner. So this is the practical example you can see with this image. This is the image of the practical failures which takes place. You can see this from another picture as well. Okay, 1 minute. Okay, so you can see this from the another picture as well. Over here also you can see that the middle section of the road got detached and the traffic get obstructed. And this type of problem takes place in day-to-day life, specifically in the rainy season. This is the huge problem which is facing by the people living over there. They get disconnected all over the country. There is a only the air way which will be present over there. So it is a huge problem. So this is only happens due to the strength of soil over there get reduced. Okay, moving on. Now we come to the some of the point that is the triaxial state of stress. So actually, if we see, if we take the soil sample, it has the three axes x, y, and z. But when we do the analysis, we interrelate the 2D simulations, and we will come to know that okay, the in triaxial also it states. But there is a specific reason for that, that why we are doing the 2D analysis. Basically, 2D analysis, one of the thing it is very easy because it is in front of our eye. We can see that, we can visualize that in 2D structure. We can also visualize 3D structure, but through 2D, if we have a good knowledge in two dimension, the third dimensions will be very easy for us. So that's why the triaxial state of stress is simplified into two-dimensional state of stress for our convenience. Okay, so what is the triaxial state of stress? The ground surface exerts stress on the soil sample in three directions, and the geotechnical material soil assumed to be isotropic homogeneous, but we know that this is the assumption. This is not a ultimate truth, but we have to assume that because the soil mechanics, geotechnical engineering, it has been taken into consideration for the several laws, several mechanisms, several formulas which has been generated by considering that the soil is homogeneous and isotropic. If we doesn't consider that, then it will be huge problem. Basically, we cannot specify that the property is varying from here to here in this manner. But we have to consider about this is isotropic and homogeneous to solve our real life problems. Okay, to simplify the analysis, the in this presentation the 2D simulation is presented, and 2D simulation problem is also solved in the subsequent slides, and you will see that how those problem get solved, and you must go across in the strength of material about that problem. But it may be case that you may be missing some of the points over there, so I have taken the very easy question as well, and one or two the difficult problem as well, that will ultimately make you understood that how those problems get solved in a real manner. Okay, so the two-dimensional case in engineering, basically we are taking two-dimensional case in engineering. So in two-dimensional case, we consider the sigma x, sigma z, tau xz, and the angle alpha. Alpha is the angle at which we can find, if we know the sigma x, sigma z, then we can find the stresses in the third dimension, in the any inclination on that plane only. We will look into that, but you need to understand that if the three dimension is there, then what is the case? In that case, the sigma x, sigma z, as well as sigma y is also there. And when we talk about the stress, the tau xz is there. There, tau xy and tau z, tau xy, tau yz, and tau zx. Tau zx is there, but tau xy, tau yx is not there. But in that case, the combination become complex, and a matrix calculation need to be considered. So that is not, I am saying, tricky, but at this point of time we can solve the problem with the help of sigma x, sigma z. Basically, we are taking the plane strength problem, and the third dimension is third dimension can be ignored, or can be said taken unity in a way, and that will help our problem to solve. And most of the problem in the geotechnical engineering can be solved taking the two-dimension consideration. Basically, if we take the soil, it will be going in the third dimension up to infinity, so we can take the unit dimension and we can calculate, make the calculation over there, and ultimately sustain our what we want to convey. We can easily convey with that only. So that is one of the case. Okay, now we will move to the interrelations which has been created with the help of the sigma and tau. and as I have talking about the sigma x, sigma z, as I go to previous slide here, the sigma x, sigma z, tau xz, and alpha is there. So there must be some relation by which we can get the normal stress and shear stress at any other plane which is inclined at angle alpha from the present plane. So we will try to solve some problems on that topic as well. But first of all, let us revise those concepts in our mind and those interrelation in our mind. So in the subsequent slides when we go over there, and one point also I want to add in that please sit with some pen or paper. If you solve those things with me in this class, that will help you a lot. And if there is some problems is there, there is one problem which you can't solve over here. Basically, that is a big problem. But other problems you can solve with me, and that will lead to the several doubts which you can ask over here only, and that will help you in a manner. Okay. So we will move ahead, and so in moving ahead, what we are talking about that there are the interrelations which interrelate the shear term tau and the normal stress term sigma with the sigma x and sigma z, and we ultimately can find the sum of the value of the shear stress and normal stress at inclined at angle alpha from that plane. Okay. So, first of all, we can see that the interrelation is given as tau equal to sigma x minus sigma z divided by 2 into sine 2 alpha. Okay, I want to convey one thing clearly over here that when I talk about sigma x, it is a horizontal plane, and when I am talking about sigma z, it is a vertical plane. And in a subsequent slide, I will also interrelate the term with sigma 1 and sigma 3 at some point of time. That will help you in solving the problem. You can able to get the major principal stress, minor principal stress. You can also get the radius of the Mohr circle. You can able to find the center of the Mohr circle, and you can able to draw the Mohr circle. And by the with the help of Mohr circle as well, you are able to solve the problems related to this topic. Okay. So moving ahead, and this is the interrelation which interrelates sigma x, sigma z, and alpha with tau. We can find the shear stress at any plane inclined at alpha from a plane where the horizontal and vertical as well as vertical stress is known. Okay. So here the Mohr circle is also drawn. You have seen that over here the sigma 1 and sigma 3 is presented, and what are those terms, how we are going to find that in a Mohr circle study analysis of Mohr circle, we are going to come across about those factors as well. And the first of all, the equilibrium equation are used to analyze this state of stress. So the question arises that what is the equilibrium equation? So equilibrium equation is basically nothing but it is the summation of horizontal, summation of vertical, which we come across on day to day in any things. We say that anything is in equilibrium. What we mean by equilibrium? If you are sitting at some place and attending this lecture, you are in equilibrium in a way. And if you are sitting on some chair, it is it is in you are in equilibrium over there. If equilibrium is not there, then you either you are going down or that chair push you up. So the equilibrium need to be maintained. Equilibrium need to be maintained during the analysis of the state of stresses. So here we are interrelating the normal stresses sigma and the shear stresses with the terms sigma x and sigma z. Basically, we are trying to find the normal stress and shear stress at the specific plane which is inclined at angle alpha from the given plane where the horizontal and vertical stress are already known. And these are also used with the help of Mohr circle as well, and the Mohr circle is generated in that regard using the equilibrium equations. We will come across that in the subsequent slides. But first of all, this interrelation is very important to solve the problem analytically, and the how Mohr circle will help. I will going to tell you in a subsequent slides with the help of some of the problems as well, and that problems will be very easy, but that will clear your concepts in a way. And I think you maybe have the knowledge of that during your strength of material course. but it is the habit of people that something is get missing over the period of time. So I will try to sharpen those concepts for you. Okay. So moving ahead, the Mohr circle basically is a graphical presentation to analyze the state of stress. And Mohr circle help to determine the stress component, that is the normal stress and the shear stress at a plane inclined at angle alpha. What we are calculating with the help of analytical method, where we are finding tau equal to sigma x minus sigma z sine 2 alpha, and in the same manner we are finding the normal stress sigma x plus sigma z by 2 plus sigma x minus sigma z by 2 into cos 2 alpha. In a similar manner, we are we can also get the value of tau, basically is the shear stress, and sigma n at any inclined plane by drawing the Mohr circle as well. We will see into that things as well. Moving ahead, there is a another terms which Mohr circle, that the Mohr circle is a powerful tool as well. But with the help of Mohr circle, we solve the various problems, the material including the soil, rock, composites. The in strength of material, you come across the these terms as well. Over there, you came to find that at a specific inclination you also draw the graphs at the chart sheet, and by which you have solved the problem. Okay, so Mohr circle is always is the analysis combined with the material properties such as the shear strength, uh, allows for the analysis in a real life situation in the civil engineering. Okay, so first of all, we see some of the sign convention. Over here, you can see that if it is rotating in the anti-clockwise direction, it is negative. And if it is rotating in the clockwise direction, it is positive. Now you must be worried about that, how we are rotating. But why we are rotating in that manner only? So if the arrowhead is if the arrow head is rotating toward the and the opposite of arrowhead, in that direction we have to rotate, and after, in that rotation, if we see that it is rotating in the anti-clockwise direction, then that is said to be negative shear stress, and if it is rotating in the clockwise direction, that is said to be positive shear stress. Over here we can see that on the top section, over there the rotation takes place in the anti-clockwise direction, so it is a negative shear stress. And similarly on the two other slices, we can see that the rotation takes place in the positive, in a clockwise direction, so that is the positive shear stress. That need to be taken, that need to be understood. Basically, when you do the analytical analysis, sigma x, sigma y, several terms are given, and you have to calculate the principal stress. Over there you have to understand that the tau x z is either positive or negative. Otherwise, if you are not able to found that the tau xz is positive or negative, then you must be in a confusion, and you are not able to solve the problem correctly. You understood that this is the shear stress, but if you don't able to take the value in a proper manner, then it will result in a several then will it will result in a problems like you are not able to get the desired solution. You think that I have solved the problem very well, but you talk to your friends that the questions is very easy, but ultimately that will result you in the marks. But the knowledge is more important thing, so you get the knowledge, and that will ultimately convert into your performance in your examination as well. Okay, moving ahead, then we simplify the terms which we have with us. We will simplify those terms for a shear failure term. Over there, earlier we have said that the sigma x, sigma z, and the interrelation for the tau is sigma x minus sigma z by 2 into sine 2 alpha. So over here, the whenever we said sigma x, it is sigma 1. Whenever we said sigma z, it is sigma 3. And how it is interrelated, we will also come across with the help of one of the images which is coming in the subsequent diagram, that will help you to great extent. And the in a simplified solution, the shear failure and the rigid body behavior is also taken care of. Now see this, important term that the understanding the state of stress in soil is a very crucial in a geotechnical engineering, and it is a very true that the how the state of stress vary is also one of the things which will result in the failure pattern. And the Mohr circle is one of the most important and powerful tool in itself that will analyze stress and the failure in soil. So simplified solution and generalization help in the practical applications. Mohr circle define the state of stress acting at a given point, which is sitting on a plane along which the failure is about to take place. Okay, moving ahead, the Mohr circle analysis. We come to Mohr circle analysis. In Mohr circle analysis, we came across the principal stresses, the major principal stresses and the minor principal stresses. So we will understand with the help of that diagram in coming slides only. And the interrelationship between sigma and tau is also stated over there. Mohr circle is basically define the state of the circle. What is the circle boundary actually represent? We come to understand that things as well. Basically, that boundary Mohr circle is the state of stress at a point plane where the failure is about to occur. If the state of stress is go one point beyond that, then the failure takes place at that extent only. But if the state of stress lie within that, our excuse me, our section is safe and we have a no problem with that. Okay, so we will see that in this regard. And okay, so this is the Mohr circle which I have made for you, and here you will understand the most of the thing. So we will see over here that in this case excuse me. Okay, sorry. Over here you can see that the Mohr circle is drawn. Over here the sigma 1 and sigma 3 is presented. The sigma 1 is the major principal stress, sigma 3 is the minor principal stress. You can find this with the help of the analytical relation, as you can draw this. You can find the radius of circle. Over here the radius of circle is represented as sigma 1 minus sigma 3 by 2. Mathematically you must have a, I think so, good knowledge of mathematics, so you can easily understood that the sigma 1 minus sigma 3 by 2, when you subtract the sigma 1 term, when you subtract the sigma 1 term with 1 minute, I am highlighting that. When you subtract the sigma 1 and sigma 1 minus sigma 3, you came across this line, and this line is nothing but the diameter of that circle. Okay, I think so you are getting that. If you don't, you can ask me anytime. Okay, so sigma 1 minus sigma 3 is the diameter of that circle, and when it is divided by 2, it is the radius of that circle, and that circle is the radius. And this is also the tau max, which we will discuss in a subsequent slide. This is the maximum shear stress which we find from that given plane. Okay, because over here the maximum shear stress is there, but at some other point, the this is on this shear plane. Over here the maximum shear stress is there. At some other point, the some sigma value is there, some tau value is there. Over here, some there are the many planes are going through. Over here, the some sigma value is there and tau value is there. Over here, some other sigma value is there and tau value is there. I think so. You are getting the my points. Now, what is the origin? What is the origin of the Mohr circle is also important. If you know that what is the sigma 1 and sigma 3, then the you easily conclude that the sigma 1 plus sigma 3 by 2 is the x-axis for these sections, and this is the x coordinate of the of this xy plane, and that is the center of the Mohr circle. And it is one of the important problem, specifically when you see the strength of material. Over here may or may not be, but understanding of Mohr circle start with this only. And when you get understood this thing, you come to solve the problem with the Mohr circle only. You are not going to do the analytical method because it become very easy. There is a relation also to find the shear stress when sigma x and sigma z is known, which we will discussing in the subsequent slide, and that will enhance your mind. That will emphasize that how easily, how easily with the help of Mohr circle we can solve the complex problem which takes more time, specifically if anyone over there is preparing for any exams, competitive exams, specifically get engineering services, the time is the most important concern. So you can see that with the help of more circle, we can solve the problem. Less calculation is needed. But when we are going in an analytical method, the problems takes more time than usual. So we will discuss those terms as well. Okay. Now here I am talking about the radius. The radius, I think so you understood that how the radius come like sigma 1 by sigma 3 by 2. Similarly, you also come to understand that the how the origin of the Mohr circle is known. Over here, the sigma 3 and sigma 1 is presented. Sigma 1 is the principal shear stress, sigma 3 is the principal shear stress, but it is principal minus shear stress, it is a principal major shear stress. If we interrelate the normal stress and the shear stress with the radius of circle, it gives the relation sigma square plus tau square equal to a square. And in this manner, we interrelate these terms. Okay, moving ahead. Moving ahead, when we go into the subsequent slides, I already said that the sigma P1, the sigma 1 over there is nothing but the principal shear stress. That is related with the sigma x and sigma z by this relation, like sigma x plus sigma z by 2 plus root under sigma x minus sigma z by 2 square plus tau x z square. Similarly, nothing sigma, only the plus and minus term in the middle section is different. Otherwise, the rest of the things are similar in a manner. In a similar way, you can also find the angle at which this things takes place, and one of the another term, that is the sigma p1 plus sigma p3 is equal to sigma s plus sigma z. When we draw we have also one problem. You see that the sigma p1 plus sigma p3 and sigma x plus sigma z always remain constant. If you draw the another stress over there as well, then some sigma x1 dash sigma z dash summation is also remain constant. This is the basic property which you come across in some of the course or of your strength of material or the structural analysis, I think, or maybe applied elasticity or plasticity if some of you are the PG students, specifically in the structural engineering or maybe geotechnical engineering. Okay, now we came across some problem. Okay, so I think we can take a 5 minute break over here, and afterward we will again continue. Is it okay for everyone? Yeah. Hello. I think
Yes,
so.
sir. Yes, sir.
Okay, okay. We will take the 5 minute break. We will continue at 4:45. Okay. And
Okay, okay, sure.
okay, I request you to remain in the meeting with audio and video off. And I will start communicating at 4:05.
Okay, sir.
Okay, okay. Thank you for cooperation. Hello everyone. Now we will resume our meeting. Okay, I have got some message from you that at the in the share PowerPoint. So don't worry about that. The PowerPoint will be shared from the NPTEL team. If Because I don't know how I can share over here, so I will not able to share right at this point of time. But it will be shared by this evening or by tomorrow. So don't to not to worry about that as well. And apart from that, the comer has asked that if I can speak in Hindi. So I can, but is there anyone who have a problem if I try to communicate? If no one have the problem, then I don't have an issue. I can speak or I can communicate with you in Hindi and English as well, part by part.
Sorry, I'm from Indonesia.
Okay,
English is
okay. Okay, okay. So I will continue in English and Kamar, wherever you got the problem in English, you can tell me. I will elaborate that part in Hindi as well. And up to now, if anyone have any issue, please note it down. And at the end, I will communicate those things in Hindi for you as well. There is no problem in that. Okay, I think so. Now I can resume. And presentation will be shared with you and not to about worry about that. Okay, 1 minute. I'm starting the meeting. Slide is visible, I think so. Hello everyone. Slide is visible. Anyone can reply. Hello. Okay. My co-host Rajat, slide is visible. Okay, no problem. Okay, okay. Thank you, thank you. I got the message as well. Okay, okay. So I will resume from here, and the presentation will be shared with you, and there is no problem in that regard. And apart from that, Kamal, if at any point of time you feel that I am not able to communicate with you in the English language, you can stop me. I will translate those into Hindi for you as well at a specific location. Okay. Now I will resume. Basically, we had less time and I have too much slide to cover, so I will resume from here. Okay. So just before this slide, you have seen the interrelation to find the principal stresses, the major principal stresses and the minor principal stresses. Now I have taken some of the question on that topic over here that will enhance your you know these concepts from the strength of material as well, but these concepts are discussed in the last week lecture. So I have taken those concepts and the problem from first of all I have taken the basic problem. Afterward what I have also taken the one of the problem over there which has given by the sir, and the solution is also stated, but I have solved that problem for you that if you have already done you can match that in this manner you can do. Okay, so now continue. So first of all I have taken a problem in which the only the normal stress, only the compressive stress is acting on a soil body, and there we are going to find the radius of the Mohr circle and as well as the principal stresses, that is the major principal stresses and the minor principal stresses. In this regard, over here you can see that the earlier during my discussion, I have said that the sigma x minus sigma z by 2 square plus tau x z square root under is the value of the radius of the Mohr circle. So over here you can also see that we have done the same calculation to find the radius of the Mohr circle, and the radius of the Mohr circle is found that the sigma x minus sigma z divided by 2. So you can see that the sigma x is 0. Basically, no force is acting in the x direction. And there is a problem. This is one of the problem with the many students. Na? If the force in x direction is not given, na, they think that something is wrong with the problem. But that not the case. Actually, if nothing is given, then that in that direction the value is 0. And in this problem only there could be another case that the shear could also act with the one of the compressive force. That is also a problem. I am telling you those things. You can take your own examples. Basically, this is not the example from any book. I have made this example from my own, and I am stating for a very basic thing. And you can also apply one of the shear force. Suppose for the tau xz of plus 20 or tau xz of minus 20, and how plus 20 and minus 20 you can easily understood with the sign convention. I think so. How you can understood? I have shown the sign convention for the Mohr circle. The similar it will act over here as well. If it is um, how it is clockwise, anti-clockwise, positive, negative, negative. I think so. You understood between the sorry, some comment is there. I will 1 minute. I will see that between the linear Mohr Coulomb and the one is good for rock or soil. Between the linear Mohr Coulomb and the non-linear. Okay, I'm not getting you, but I will come talk to you in the last of the meeting. Okay, 1 minute, 1 minute. Again, I have to go to presentation. I will take all your comments at the end. Okay. So first of all, in this problem, the shear stress has been found. Similarly, the sigma x plus sigma z by 2, the interrelation which we will discuss just earlier. Uh, in, with the help of that, we have calculated the major principal stress as well as the minor principal stress. Afterwards, the one more concepts which we discussed three slide earlier. Over there, we have discussed that the principal stress could be plotted. Over here, you can see that the 0 is the one principal stress and minus 30 is one of the principal stress. So this is the minus 30 and this is the 0. Then the question arises that what is the center? What is the center of the this Mohr circle? So you can see that the center of the Mohr circle is nothing but sigma x plus sigma z by 2. So minus 30 plus 0 by 2, that is minus 15. And second coordinate is 0. Basically, it is going through the x axis. So that is minus 50, 0 is represented over here. One of the thing which is not which is over here, but with the help of that you can understand one more thing, that you come to know that the radius of Mohr circle. So radius of Mohr circle is sigma p1 minus sigma p2 divided by 2. So 0 minus minus 30 by 2 is nothing but 15, and that is the radius of Mohr circle, which is also shown over here as tau equal to 15. I think so you are getting my point, because this is a basic, very basic thing. I think so. I am able to communicate those things to you. Okay. Now I have reversed the problem. When I reverse the problem, we have the compressive force is 30, but on the same plane is the tensile force is acting. Our Mohr circle gets shifted rightward in a similar manner as earlier the compressive force act on that panel, but now the tensile force is acting. And now you can see that when you calculate in the same manner, you can see that the principal stress, major principal stress and the minor principal stress get the opposite sign value, and it will get transferred in the rightward direction. And similarly, you can see that the center of this Mohr circle is nothing but sigma x plus sigma z upon 2, that is 30 plus 0 by 2, that is 50, and y coordinate is nothing but 0. And similarly, when we get it from the analytical, it is also giving the 15 only. But over here we got from analytical and we have plotted on the Mohr circle. Again, a different problem also I have taken, in which I also apply a force on the in a x direction as well. Over here you can see that in all the direction the tensile force is acting, and for that when we calculate, the radius is found to be 0, hence the 0 radius Mohr circle is there. But at several exams, this is a very at any competitive exam, at any places you go na, this is the favorite question of the examiner. They ask that how, they ask that they ask this type of problem, and when you get the radius as 0 you get confused. And at that they doesn't stop, you have to find that those radius, the point Mohr circle is found at the right side at which distance. So when you calculate the sigma p1 and sigma p3, both is getting 30, and that is nothing but these things we got from the same interrelations which we have earlier used. Anup, please mute yourself. Thank you. So over here, the sigma P1 and sigma P3 we have found with the help of the interrelation which I have just explained in the two slide earlier. So you can see that the major principal stress and minor principal stress, which we are calling from earlier, sigma P1 and sigma P3, both value is same. So the basically from the sigma p1 minus sigma p3 by 2 is the radius of the Mohr circle. So 30 minus 30 by 2 is 0 only. So this Mohr circle is of 0 radius present at the 30 unit from the y-axis. Similarly, you can also take the similar problem over there. The all the forces are of 30 kilonewton acting in the compressive direction. In that case, what you come to find? You will find that in that case, the point mover circle found at the left side of the y-axis at the same distance. You can try this at home, and there is a no problem. That is a basic things, and it will help you in some way or the other. So please try those questions. Make your own questions. Basically, this is a type of game. You will getting enjoyed if you are going to prepare your own problem and getting solved now. It will give you immense joy. Okay. And basically, I always believe that the learning is not to I have to study. This mindset should not be good. I have to study. The word is same, but the our expression I have to study. I have to study. Huh. The mindset gets changed over there. So I'm not a motivational speaker. I'm not going to tell those things in detail, but in a sense, the learning is most important things. If you get learned, it always get benefited. The getting exam, getting degree is another aspect that will help in very much manner. I am not disrespecting those things, but the learning is an important process. So try to learn, try to frame your own question, try to take the different value at tensile, compressive, and try to form the Mohr circle. That will help you. I think so. Most of you are from the some of the academic institutions, so it will enhance your understanding about the Mohr circle, and the Mohr circle is the most important thing in the strength of material as well as the geotechnical engineering. And the various questions are framed specifically for I am talking about the students who are from the different organizations and trying to take the exams like their state services or engineering services or maybe get exam specifically. They will get benefited from these exams because if you take their own example, make their own example and solve the problems. Okay. Now I am going ahead. Over here, you can see that I have taken another problem. Over there, in one plane, the tensile force of 30 kilonewton is acting, while on the other plane, compressive force is acting. Now, when we draw the similar things over here, we come to find that here the radius of 30-meter Mohr circle get formed, and the major principal stress and minor principal stress is plus 30 and minus 30, and origin of the Mohr circle is at the 0, 0. So you come to know that this is the one of the problem, and another things you can also expect that there is a no tensile, no compressive force is acting. Only shear stress is acting on all the plane of the same magnitude. Then you will calculate that what is the things you are getting. So then you also got the radius as the shear only. The what is the value of shear is the radius of that circle, and the major and minor principal stresses are plus tau and minus tau. That you can also draw, and you can find out how I think I am able to make you understand that there is no tensile, no compressive force is acting. Only the 25 kilopascal stress is acting on all the plane. Only 25 in this plane, in this plane, in that plane, in that plane, all that plane. 25 kilopascal stress is acting. Then you also draw your own Mohr circle. Try to do that. It will help you. It will increase your concepts. And if anything problem arises, you can ask me in the subsequent classes as well regarding those things. I have no issue that in the previous lecture what I have taught, I am not going to discuss in the next lecture. This type of thing is not with me. I welcome your questions in subsequent lectures as well. Okay. Now I am moving to the next concept, that is how we are going to take some more problems also, some good problems, some and basically some difficult problems sometimes. Difficult is nothing, only the mindset make it difficult, or mindset is thing. Basically, you have seen that in any exam you go and you see that the first two problem are very easy. You solved quickly. Then the third problem is little tricky. Tricky is a good thing, but not difficult. You also able to solve. But if in a exam paper the first problem is tricky and you get stuck over there, then easy problem also got solved in more time than usual. So Nothing is difficult. It's all about the mindset. The how we go to take the problem now in our mindset. If we are feeling that no, these problems are not very eh, not very problematic for me, then it will be easy for you. The basic thing is mindset. If you go with a good mindset at any place, it will help you. Okay, no problem. We are moving in forward direction. Over here, the applications in civil engineering, the Mohr circle or the analytical method, whatever we use in a civil engineering application, specifically in hilly terrain. I have said that there are the several problems in hilly terrain, like cutting slopes and creating benches in road pavement. Over there, the application of these things can take place. It also help in understanding the critical state of stress. As from the previous example, we have seen that the Mohr circle gets shifted rightward, leftward. Maybe some point Mohr circle get formed. Maybe some different combination can be created, which I have said you to make take your own example, and it will not take too much time. Hardly if you can take different examples of your own, and it will hardly take 15 to 20 minutes to solve that, and you are too much confident in that topic afterward. Okay, no problem. So a real life case study of the stabilizing slope and construction retaining wall. बिल्कुल हाँ, specifically in these things you are going to use this. Okay, moving on. Now we are going to generalizing the law. Now there is a one thing, active earth pressure and passive earth pressure, which we are going to study in this coursework. But over here the primary input I am trying to give. Basically, we have seen that the sigma x we have taken in the horizontal plane and sigma z we have taken in the vertical plane. If I think so, you may be familiar with the earth pressure, but not at such extent. But if someone of you, for your reference, I am telling, but if any one of you don't get these point, don't worry about that. We will discuss elaborate in the coming classes, not next class, but in coming classes we will discuss those things as well. But those who have some knowledge, I try to give some reference from there that they will understand if they have some aspects of that. That you have seen that active earth pressure and passive earth pressure. The active earth pressure is the thing when the retaining wall is moving away from the soil, while the passive earth pressure is that when the retaining wall is moving toward the soil. So when the earth is moving toward the soil, it exerts a pressure on the soil which lie over there. It will ultimately result in increase in the stress in the horizontal direction as compared to the vertical direction. So in that case, the passive state of matter is basically passive earth pressure. If we talk about the soil, but similarly, if if the soil mass is there and it is exerting pressure and wall is going away, then in that case the earth pressure is the active earth pressure, that is the active state of material. Try to explain with this example. I think so. Some of you must get this thing basically if you have some understanding about the active and passive earth pressure. Otherwise, not need to worry about that. We will take this thing in elaborate form in upcoming classes. Okay, now we will move ahead. Now the pole. Pole is a term which is one of the term which is discussed that it is a point on a Mohr circle through which all the planes pass. All the plane passes through the pole, and pole can be represented in a versa term as well. That the reverse process, the drawing the line passing through the pole to determine the state of stress on a plane. So this is also the thing. Okay. Now the generalized state of stress we are generalizing. Basically, we have discussed the analytical method. We have discussed the Mohr circle method. So the generalized concept is created in our mind that, but through the Mohr circle method, maybe someone is more familiar with the diagrams that they make the graph and they solve the problem. They can visualize the things, and Mohr circle is in itself the state of stress is presenting, so it will help in the real life situation. Sometimes you have to draw the Mohr circle, but someone is good with analytical, so we generalize the concept in both the term as well. And as I have already discussed the sign convention, the some points are mentioned over there, so no need to. I need to read this. Okay, now I have a problem which, if you have gone through the lectures in the lecture number 5, sir has given this problem, and sir also stated the solution. I have solved this problem for you, and I have also added some thing for point for you, so you can look into that. Here we are getting that how the origin is like minus 52 compressive stress is there, minus 12 is there, so minus 52 minus 12 this stress is drawn. The origin is found like minus 52 minus minus 12, that is plus 12 by 2, and by that you are getting, sorry, sigma p1 plus sigma p3 by 2 in the sigma x plus sigma z by 2, similar same thing, you are getting the origin as well. And afterwards, here the question is not this, this is the additional component which I have implemented, no need to worry about this. The main question over there, that if the sigma x and sigma z is known, then what is the value of the normal and shear stress at the angle 35 degree from the horizontal? I think so you are getting the problem. Over here written as well, the stress at a point in a soil mass at 35 degree using the analytical method. So at the starting only, I have written the analytical method like sigma x minus sigma z by 2 sine 2 alpha is the shear stress. By that method, when we calculate the sine 2 alpha, alpha is a 70 degree, 2 alpha is 70 degree. So we came to know that the shear stress value is nothing but 18.79 kilonewton, and similarly the normal stress is also calculated. I think so. You might be already solved this problem, but I have taken this that we are getting the same answer. There are some more problems also over there which you can solve with the similar concept only. Okay. Now I have taken a different problem over here. The tensile force of 100 tensile force of 100 kilonewton and the 50 kilonewton is acting on each of the horizontal and vertical plane respectively. On horizontal 50 and on vertical 100 kilonewton, and we are going to we are going to find the shear stress, no, we are going to find the principal stresses, major and minor principal stresses, through the analytical method as well as through the Mohr circle method. So this is the little important thing which you will understand. And I can see that over here the shear stress is minus 25. If you see the vertical plane, it is moving in the anti-clockwise direction. If I am now wrong, okay. So you can see that the sigma z value is plus 100. From the graph, you can also see both are tensile. Similarly, sigma x value is plus 50, both are tensile. Similarly, tau x z, I said it is uh, sorry, it is minus 20, it is minus 25. Now you can see that we have calculated the sigma p1 and sigma p3. Not only that, you can also find that when you add 110.36 plus 39.64, that is equal to 150. And as I have tell earlier as well at some slide in the presentation, like sigma p1 plus sigma p3 is equal to sigma x plus sigma z. Here the justification is also there. I think so you are getting my point, that sigma p1 plus sigma p3 equal to sigma x plus sigma z is justified with this example. And this diagram is also drawn over there. You can go through that afterwards. Okay. So over here, if we want to draw the Mohr circle, so what is the radius? The radius is nothing but sigma x minus sigma z square plus tau x z square root under. That is the radius term. Sorry, that is the radius term over there. And the what is the center? When you find the sigma p1 and sigma p3, then the center of that thing is nothing but, I will also calculate with you. If 1110.36 plus 39.64 by 2, that is 75. 75 and 0 is the center of that. And similarly, if you want to find the radius, that is 110.36 minus 39.64 upon 2, that is 35.36. I think so you are getting this point, that what I am talking about. The what center is sigma p1 plus sigma p3 by 2, and 0 radius is sigma p1 minus sigma p3 by 2. So you can draw the Mohr circle for that also over here. Now I move ahead. Now you can see that you can also find the at which plane this angle will getting formed. So for that also you have seen in the previous slide that the relation is there that tan to theta is equal to 2 to xy by sigma x minus sigma z. From that you have go through these things in the strength of material as well, but over here in the subsequent slide when we relate the sigma 1 and sigma 3 in the triaxial test, you came across these terms again. So this need to be boost up for you. This concept need to be brush up. Basically, these concepts help you over there during that time when we discuss the triaxial test. We discuss the different interrelation. We might be deriving some things and that how sigma 1 and sigma 3 get related. So these concepts will help you. That's why I have put in this problem. I think so. That's not the problem. And what I am talking earlier, the sigma x plus sigma z is 150. But at this plane as well, the sigma p1 plus sigma p3 is 150, and this is the basic concept. If we form at some angle as from this plane at some angle we want to frame any stress component over there as well, the sigma means the horizontal and vertical, the two normal components which form on that axis remain 150 only. And this is the basic concept which I have told you in a very first in a very earlier slides. So I think so these things are clear with you. Okay. Now I will go ahead with that. Now I will take this problem only with the help of Mohr circle. So in a Mohr circle, when we are going to see the Mohr circle, so here you can see that we have the stress of 100 and 50. 100 is also tensile, 50 is also tensile, but one is minus 25 shear stress and one is plus 25. So for that we have to put our plot our sections at we have to put our point at 125 and 50 minus 25. Afterward we draw a line, and from that we draw a circle which is passing through both two points, and this circle cut at two sections on the x axis, the normal axis. Those 2 points are the principal stresses. Over here, the similar thing has been taken places. The value of P1 is 110.64, while value of P3 is 139.36. You can do on the graph paper at your home, and you will get the similar result. You take the scales, you take the sum scale, you take the origin, you plot this point, you plot this point, then take a sorry, take a compass and you draw a circle. Afterward you find the position of the principal stress and major principal stress and minor principal stress over there, and I think you must be going to do this, and this will help you. This is for your reference only, and this will ultimately help you, and no one have compulsion to do so. So it is seen that if there is no compulsion, no one is going to do, but by humble request, please solve this problem with your hands, then you are going to get these points. And for your reference I have also kept that thing which we you will get interacted with, and ultimately you have seen that one more point also I want to mention, that the in a Mohr circle, the here we find the angle. So the angle over there we find is the we get 22.5 degree. Over here when we get tan inverse, and tan inverse this length basically JG and JG by JO, then that is 45 degree on the Mohr circle, that is divided by 2, that is the angle which is making with the principal plane 22.5 degree, and both at a 90 degree difference, so 22.5 and 112 degrees. Similarly over here we got the 45 degree, 45 by 2 is 22.5 and plus 90 is 112.5. I think so it is little tricky, but if you go across, you draw with yourself your hand, then you will able to understand. This is not very important. This circle we are not going to draw in a soil mechanics to a large extent, but little use is there, and interrelations which will establish the relation between sigma 1 and sigma 3 during the triaxial test will help you. So try to do so at your home, and it will help you it must will help you. Okay, now we are going to the last portions of the today discussion. So these are the topics which has been not taken in that extent during the class, but this will the basic things which you need to understand before going in a deeper concept. But in the subsequent classes, these things are coming for you. But I have taken some of the points which I want to discuss over here. Okay, so what are those points in my mind? I will try to communicate with you that the relation between the basically shear strength is the function of the normal stress sigma the function of sigma, and the interrelation S equal to C plus sigma and tan phi. You most of you are familiar with, I think so, may or may not be, but at some point of time, if you have studied the basic soil mechanics, basically geotechnical engineering one, you must came across these terms. So I feel that you may not know the significance of this, but S equal to C plus sigma and tan phi, the basic theorem, which is basically if we say the Mohr-Coulomb failure criteria from where the shear strength at some point of time at some institution S equal to C plus sigma and tan phi is only used for interrelating the shear strength with the normal stress, and from here only they start. After that, they discuss the direct shear test, triaxial test, and the rotational test. The name I don't recall at this point of time, but I will tell you. Okay, so over here the C is the cohesion and phi is the angle of internal friction, and I will again explain what is the cohesion and how on which factor it will depend, and what is phi and on which factor it will dependent. Okay, now, in saturation condition, basically, we whenever we take, you must have read the effective stress, which is the chapter 2 of the geotechnical engineering one. The effective stress is there. Over there, you have understood that what is the problem due to water, and water is one of the biggest problem for soil. It will reduce its strength up to a larger strength. At some point of time, it will reduce its strength to half if it will be completely submerged. You must be going through the geotechnical engineering one. There you have studied about the total stress, effective stress, pore water pressure, how the pore water pressure affect the soil. Soil, the water is the biggest enemy in a real world. If we say no, the water is the biggest enemy of soil. So you need to understand that why we are taking the effective. Whenever we study either over here, either we are going to study earth pressure, either we are going to design retaining wall, we always consider the effective soil, effective stress. Everything is a function of either shear strength, either we are designing the foundations. At every places we are considering the effective stress, not the total stress, because earlier you there is a news over there that earlier the Mohr-Coulomb theory is used at the total stress, not new, it is a real fact. But on that basis, the several structures are designed and several big structures are designed. But once a earthquake occurs, and during the earthquake, the water level rises to a higher extent due to vibration, and this will result in the type of liquefaction, not real term liquefaction, but this will reduces the strength. Basically, sigma is the total strength, and if we reduce the pore water pressure, its strength reduces. If the water level rises in the ground, it will result in the reduction in the strength. So ultimately, it will result in the collapse of structure which may be presented over there. So we must need to understand these things, that what needed to be entertained and what needed not to be entertained. So that's why in soil mechanics, in geotechnical engineering too, everywhere we are using everywhere we are using only the term like everywhere we are using term like effective stress only, not the total stress, because the total stress has so much problem with itself. Okay, so over here there is a representation is shown for you. In this representation, you can see that the S equal to C plus sigma and sigma dash tan phi represented, where sigma dash is the effective stress, which is the total stress minus pore water pressure. Okay, so here the total stress minus pore water pressure, and it is also represented in the graphical form. Here you can see that the angle at which my axis is inclined with the x-axis is the angle phi, and the value on the y-axis from where the graph is started is the cohesion. So you can easily understood that how this is interrelated. We will discuss these components in detail in a subsequent classes. But as of now, you should get the basic understanding with this one. Okay. Uh, 1 minute. I will communicate with you in a 1 minute. My laptop is getting discharged. 1 minute. Laptop charge. Charge on. Charge. Okay. Sorry for inconvenience. I will resume now. Okay. So here uh, the term which are the cohesions and pore water pressure you must have understood, and this is the basic thing. Now I will in the today discussion with some of the key term definition, that is the shear strength of soil, which already I have discussed, but I will read these things for you at last again. That the shear strength of soil is the maximum internal resistance to the applied shear forces, while the effective friction angle is a measure of the shear strength of soil due to friction. Hmm. Friction angle is nothing but this phi. While the cementation is a property by which the soil can be held together. So cementation is a measure of sorry, measure of shear strength of soil from forces that the cement of particles. And now cohesion. The cohesion is nothing but which is shown over here. Cohesion is also the property of cohesive soil. Mostly the cohesive soil has huge cohesion, and cohesion sometime when we go to design foundations, we come across the C and phi value and C5 soil, C soil, and over there the several interrelations are also there on the basis of C and phi. In the foundation engineering, the Tarjagi, Marov, when we use those interrelation on the basis of phi in various parameter like NC, NQ, and gamma, you might be familiar with or you may not be, but those things are found on the basis of phi and C value only. So it is a most important term in a geotechnical engineering. Okay, so apparent cohesion is the apparent strength at zero normal effective stress, and this is one of the most important and most interesting term which I will explain, but not today, because some of the prerequisite is there, some of the other knowledge should be there. Basically c dash S equal to C into sigma and tan phi. There is a term is there where Sn is some number known as some number, and the cohesion is not used up to its extent. Afterwards, the apparent cohesion is come. Basically, C dash is the apparent cohesion, that is C by FOS, C by factor of safety. I will explain those terms. Okay. So critical state is a stress state reached in the soil when the continuous shearing occurring at the constant shear stress to the normal effective stress ratio and a constant volume. Okay, these are the basic terms which you need to understand. These are the terms which I have put, so you will get some of the points. Afterward, we will discuss those terms in detail as well. Whereas the last term key point is dilation. Dilation is a measure of change in volume of soil when the soil distorted by shear. Okay. Now, the some of the output which we come from the today discussion, which I try to mention with you, that this course geotechnical engineering 2, today we focus on the shear strength of soil, the Mohr circle, uh, how this Mohr circle will be used, how the analytical method will be used, how this is a tool which will enhance our capability in the stress analysis, that we have understood to the some extent, and I will request you to solve some of the problem, specifically the Mohr circle problem. Through you take a graph paper, you plot those points like the 100 and 25 and 100 and minus 25, You draw a straight line crossing through the x-axis. You take some skill, and afterward you keep the compass on the x-axis where it is cutting, and make a length and draw a Mohr circle and find the value of the principal stresses. And before that, then through analytical method, we have calculated the match that if that value is coming or not, and that will boost your confidence. Once you getting those things, na, you will get enormous confidence in yourself. Yes, that whatever the I have read, those things I am understanding and also capturing. So this is my request. Please go through that. Apart from that, the you audience get encouraged from this by problem solving the problem of Mohr circle. What I am talking about, I try to encourage you in a manner as well. So that thing I am mentioning over here as well. Okay. Now some of more thing I want you to do. This is not the compulsion. This is the task from my side. If you if you want to get more benefited, and if it is not a word, you must need to be benefited from this session. Otherwise, why you waste your valuable time? So please try to write some point that what is meant by shear strength of soil. Try to study about that and factors affecting the shear strength. I have tell about some of the point, but not discuss the factors in a real manner. But you can go across and found that what are the factors that will enhance the shear strength, that will reduce the shear strength, on which criteria, what are the problem with shear strength. You can see the find the some of the images that how the shear failure takes place. You are also come across the several point that the shear strength can, how the shear strength can uh, demonstrate a building, how shear strength can, how we can enhance the shear strength. You can, this is a different topic, ground improvement, but some points you can interrelate. You can make the sum of the, you can found the sum of the images where the shear failure takes place, and that will see you that the parent body and the detached body example I have shown you. You can find several images like that as well in Google when you go to search. So please find it and please understand. Please see the practical example, practical implementation. Basically, whatever you are reading for the practical use. Theory is okay. Theory you need to understand, but the practical implementation is equally important. So please try to do so. And apart from that, what is Mohr circle? As a definition, please write. That is also present in this presentation only, and this presentation is going to be shared with you. Don't worry. And the properties of Mohr circle, with the help of Mohr circle, some of the property I try to mention today, well, this time present only, but you try to write with yourself also, that with the help of Mohr circle we can find the center, we can find the radius is the tau max, and we can find the principal stresses if we got the sigma x, and tau xz we can draw the Mohr circle, and with the help of Mohr circle only, without doing any analytical analysis, we can find the value of the principal shear stress, that is major principal shear stress minus principal shear stress. With the help of Mohr circle, you can find the maximum shear stress, you can find the value of the shear stress at the normal plane, you can find the value of shear stress at the normal plane, that is zero only. I think so. This point I haven't clarified, but you will understand that at the normal plane, basically on the x-axis, where the Mohr circle cut, the value of shear stress is zero, always zero. You have seen that on the x-axis, the value of x coordinate is there and y coordinate is zero, basically because on the principal plane shear stress is zero. This is the basic definition from the strength of material. Okay. Okay. So what are the properties of Mohr circle? Please write that. I have explained many at this point of time as well, but please try to write by yourself as well. At this is the evening time, so at night please sit and try to write this problem with your own. Try to search something, some images which will show you the clear picture. And in this presentation also some images are there which will be shared with you. Okay. And apart from that, I have tell you earlier as well, but solve four problems related to Mohr circle from any book, or you can frame by yourself as well, but try to solve from book only. Basically, they have planted the question in that manner that you can find the you can draw those circles. The questions are not manipulated. The questions are framed in that manner that you will able to solve in easy manner. So try to solve it from book only. And apart from that, what I have told you to solve the problems, taking the tensile compressive force, taking the shear force only, taking the shear force and normal force in one direction only, taking the shear force and normal force in compressive direction only. This will enhance your understanding of the topic in a broader aspects. Apart from that, I have referred these of the some of the things, specifically these two books for this presentations and as the NPTEL lecture as well. But basically, you have seen that the whatever doubt over there, I have tried to revise to some extent. I also take some question which maybe I think so, which will help you. That the feedback I always welcome. You can write in the message as well that you can give me some suggestion that what extra I can do that will help you at the greater extent. And apart from that, I think so done from my side. So any suggestion if you want to give, you can give. Basically, the session time is going to be over, and so I want to, if anyone and Kamar, if you have any confusion at any topic with my language, specifically any topic, I can communicate with you in Hindi if you want. Okay, you are not there. No problem, no problem. So I think so. With this, we can end our session. Thank you for attending this meeting, and I will hope you will come on the next week as well. And at
Sir.
some and at some extent, it will help you. And these videos are also there in the YouTube, and those links will be shared. If not shared, please tell me the next video. I will try to make it clear that it will be shared with you without any problem. But I think so the presentation and video will be shared by tomorrow. Must by tomorrow or in a 1 2 day it will be shared. Basically, I have to upload this on YouTube. Then I will share those links with the NPTEL team. They will share with you. You can go across that again. And if any one of your friends are there, if they want to see my this course, this 2 hour lecture, then they can go across. I think so this will be useful for you at some extent. Okay, so with this we will end our session. Thank you everyone. Have a very good weekend. This is a small weekend, but thank you for attending everyone. And now I am ending the meeting. Okay. Okay.
Uh,
Yes sir, please ask question.
Thank you. Actually, I learned rock mechanics, but in some situation, it's hard for us to determine because more column use linear and hook ground use non-linear. So, which one is good for rock or soil? That's my first question.
See,
Okay,
rock
and then
here. Okay, okay.
uh,
See,
actually,
I
I
am
have a few questions.
there are
The
too
second one
much
is
noise in your background, so I have an
also
what?
uh,
Okay, please tell, please tell. Now I'm listening.
okay. The second question is um, in two-dimensional we use plane stress.
Okay.
So what is why I have to use ground stress? I mean, when I use rock and soil 3D, what is the urgent of use that? I mean, if 2D
See,
is good, so why we have to use 3D?
okay, okay.
The second
In geotechnical engineering, basically up to UG level or specifically in PG level as well, what I come in my knowledge, that the 2D in geotechnical engineering, the 2D problems are sufficient to solve the most of the problem. We don't have to enter into the 3 dimensions. Basically, if you are going into the higher studies, specifically in PhD, You will take the sum of the problem in three dimension as well, but up to that in third dimension we consider the unity, and we know that it will extend up to infinity in a dimension. We consider that, or otherwise when you go to the triaxial test, and in triaxial test the sigma 1 and sigma 3 related, we somehow considered sigma 2 is equal to sigma 3, but in the analytical solution we use sigma 1 and sigma 3, but in triaxial test, I am taking the example of triaxial test. If you have some idea, then you will get that in triaxial test the stress is acting from all the three dimensions. From the upward direction it is the deviatoric stress, and from the confinement in which it is kept. I am going to discuss the tests in next lecture. So the stress is acting in the all the dimension, but the direction the sigma x and sigma y. If I consider this is sigma x and perpendicularly sigma y, the stress is considered same. So the third dimension is considered to be same, and calculation is based on the vertical and only one horizontal direction. And the plane basically in applied elasticity, if we have gone through, there is a plane strain problem. In this case, in that case, we consider the third dimension as infinite. So we can neglect that, and with the help of sigma 1, sigma 3, the most of the basically 95% of the problem we can able to solve, or more than that, in geotechnical engineering. So we need not need to be consider the third dimension specifically for the geotechnical problem. And the another question of yours is related to rock mechanics. That in rock mechanics, linear Mohr column or the non-linear hook broad. So I have not too much confident about this topic. Basically, I have not gone through rock mechanics to such extent. But if I want to convey that the Mohr column is not too much sufficient for the rock mechanics, as of my knowledge, but I'm not confirming. But I will try to answer this question in the next lecture. I will read about that, and I will try to communicate with you about this problem. I'm not too much confident, so I either telling anything to you and saying any wrong thing is not a good thing. So I will read that, and I will come to you in the next class, and I will answer those problems. I think so. That will be okay for you.
Yes, sir.
Okay, okay. I will try to answer in the next class about this problem, that how the rock mechanics and soil Mohr-Coulomb theorem, Mohr-Coulomb analysis, or some other things should be used. I will try to answer in the next class after reading. Basically, don't have the broad knowledge in that aspect, so I tried. I don't want to answer any wrong thing. Otherwise, I will say that sorry, I don't know today. I will answer in the next class. Okay. I think this will be okay for you. So I think so. Time is also getting over. So if meeting get all automatically closed, so it is better that I will close the meeting. And don't worry, you will get the link of the presentation as well as the this meeting YouTube video as well. Okay. Thank you for attending this meeting. Wish you all the best. Wish you all the happy weekend. Very small and happy weekend. Okay. Thank you.